solve the heat fin equation. So if your cross-section keeps changing, then the heat equation you want to use is that one. But if you are something like straight rectangular or straight cylinder like with pin or straight triangle one, then you can divide the AC and then you can use this kind of second order differential equation to solve it. And then it turns out then there's a general equation. It's a constant times the hypercosine n, and there's a function of the distance, and another constant times the hypersine n and times the distance function. And this is the general equation of the fin equation, which the cross-section didn't actually change that much. Okay, that's what we learned. And then later on, we kind of summarize the different types of the fin, which is widely seen in the daily life. For example, the straight rectangular one and pin one, and sometimes because of the manufacturer, then they use the triangle one and then triangular one. The triangular one usually is like they use the milling machine to do the engrave. And the length of the triangular one isn't that high. 三角形的散热片，有时候你看到的时候，它其实是用那个洗刀，然后它那个洗刀是有一个锥度平洗刀，但是它在平面当中直接洗过去，所以它深度不会太深，但是它看起来就像一个 grave 的样子。那这种东西我们也是把它视为 triangular 的 fin， 所以有时候有一些 fin 没有太长，散热体是没有太长的话。 通常会用这种方式，那它是制作上面速度很快，比起这种那种 aspect ratio 很大的这种 straight rectangular fin 制作上面来讲还要简单，所以这个地方也算是蛮常见的。Okay, so we describe those fin equation, how we can calculate it, and then directly fit with the textbook. So if you can refer to the PDF, that would be great. Then we have different kind of cases. For example, the first one, we assume the fin is quite long, the L is quite long, and the tip of the fin directly equals to the temperature of the environment. So we call it infinity long fin. 那它不是真的 infinity long， 它的意思是指说我 fin tip 端那个地方。 的温度指的是环境温度，它没有再有一个温度架的一个这样子的 case. So we start with the boundary condition. We just mentioned the tip, the theta L will equals to the environment temperature, and also at the base equals to the base temperature. 有这两个 boundary condition, then we start to solve our equation. And then we found that in the axis temperature, or we have a normalized temperature function equals to exponential minus mx. 是一个 decay 的函数，exponential 的 decay 函数 ，and the m equals to the function of the fluid property h, and the material property k, and also the shape issue. P divided by area， 我们有两个 function 跟周围液体，不管是空气或是水有关的 H， 跟 material itself K 传导系数有相关的，以及 P 除上 A 它的几何形状。OK， 所以这个 decay function 呢就跟这几个东西有相关。Then if you want to try to find out the rate of the heat transfer, then you can directly use the Fourier law minus Ka dt dx or d theta dx. Then you can get this n root square and then have the theta times of it. 就是你的 n 去做一个开根号之后，然后m square 其实就是 m 嘛，不是 m square，m square 开根号所以 m， 然后乘上你的 theta 就是你的温度差。Okay, so those are the material what we have until last week, and then we described quite a lot of stuff, and then we described how we calculate the heat transfer. Then we need to move to the second case. The first case is infinity long fin, and the second case means you have a insulate stuff on the tip of your fin, or a diabatic situation 在你的 tip 的顶部，它是一个绝热的现象。但这种 case， 那通常这种 case 呢，一定会是有限场limited length. Okay, so then therefore we have several boundary conditions here. Okay, the first boundary condition will be at the tip, then you have your slope of the temperature versus the position will become zero. 因为你是绝热，我们讲过好几次了，在绝热那个位置的时候，你的 d theta dx 它就会等于0。So if we draw a figure, let me try to draw it. X and t, then you look like this, then definitely at this point, the slope will equal to 0. 这是你的 boundary condition. Okay? And what else? Another obvious boundary condition is similar to the one we have at infinity, is the theta x equals to 0 will equals to theta b. 可以吗？当 theta 的 x 的位置是在根部的时候，它的温度就是直接等于 theta b. So let's drive the equation. So let's draw this again. Then you have a length of L. Then you have an insulate surface on the tip. Then of course you can start with the governing equation. Then you have exponential blah blah blah. Then but we can just write it down because we already done this before. So the theta minus HP Ka theta. Yeah. So then this is become. Then I just write down the total solution quickly. Okay, so let's put in the boundary condition we just mentioned. So when x equals to 0, the theta will equal to theta b. And at the tip part, x equals to L, the slope equals to 0. So those are the two boundary conditions we are using. Okay. Okay. So from the first boundary condition, we got the theta b. Equal to C1 plus C2. Okay. And the second one, the 0 become. Let me do this first because there's some of the students says it's better to write it down more clearly to remind them the mathematics. Minus m C2e minus nx. OK， 好，这就是普通的一阶导数。First order derivative. Okay. Then actually this form a new constant. 可以吗？它其实就是一个新的参数，因为 m 对你来讲就是材料的系数加上几何形状，所以它本来就是一个常数。那它因为被一次微分之后呢，到前面的系数之后，它还是一个新的常数。好，所以我们的 equation now is become C1 ml minus C2e minus ml。可以吗？好，我把 L 再带进去我的 equation 当中。Okay, so from this, I know C2 equals to theta b minus C1. And then if I put it into the later equation, 0 equals to C1 e and L minus theta b e and minus L plus equals to theta b E minus ml E minus ml plus EML. Then you can stop here, but if you want something more concise, then I will times EML for each term. Then it will become theta b at the top and 1 plus E2ML. Then of course you put it back into C2, and you got the C2, and then I won't be writing up again, so I just give you the total answer of the theta x. That will equals to theta b, that's a very long one, times, let me try to write it down, 1 plus E2ML E mx plus, wow, that's a very long, let's try to squeeze it, E2ML 1 plus E2ML E minus mx. Okay. Mx. I move them a little bit. Don't forget there's a theta b, then you write it down here. 好，你把 C1 求出来的值带进你跟 C2 的 relationship 之后，你就可以得到整个 theta 参数。哦，看起来非常非常复杂，这个就是顶端是 insulate 的状况，哦，它会长的样子。好，之后还很麻烦，还没结束哦。好 ，Let's take this to the next page。等一下会讲更简单的解法，但那是补习班会讲的，但课本上还是要先讲一下。Okay. So if we take a look at the term of the EMX 1 plus E2MX. So if we try to times the E minus MX for each of them, let's write it down like this. E minus ML and E minus ML, and the bottom one will become only ML, okay? And this will become E and L divided by X minus ML plus E and L. The reason we are doing that is we try to find out the relationship between the X and the L. So we try to intentionally to do it. 我们只是为了数学的关系，来希望上面这个 term 是跟 x 减掉l 减掉 x 有相关的。我们等一下会讲，它等一下整理起来的整个看起来的样子。So now the whole equation, if we put the theta b on the left hand side again, so the whole system now become E and x, E and minus L, E minus ML plus E ML plus EML E minus x, E minus ML plus EML. Okay? So now the upper one here will become E and XL. And here similar E and X minus L. Okay, so what's the importance here? Let's note here, if you guys remember, theta, no, sorry, E and X were equal to hyper cosine and theta plus hyper sine and theta。它就会它的通解，不是通解啦，它是可以写成这样子的形式，可以吗？好啊，如果是前面是负号呢，一样，好，正负号的话，这里就跟正负号，好。好，所以那你现在的西塔现在变成 L 减 x， 所以我就把它代换进去。So the whole equation will become 2 cosine, hyper cosine n L minus x cosine hyper cosine m L。课本当中的公式就从这个地方来，按前面把2消掉，好，2不要看。重点在这一项，好，你要知道 exponential 的 mx 可以把它写成 hyper cosine 跟 hyper sine 的结合，然后把它带进去之后呢，你就可以有效的把它整个方程式做简化。那上面就是跟 x 对l 有相关的值哦，那 m 都才留着。太辛苦了啦！如果我们知道 general equation, let's do it again. We actually already know the thing general equation. We can start from this c1 cosine hypercosine. So last week we already mentioned this general equation we have. So at this point, then we just apply the boundary condition. Then you already have your equation. So if you know the general solution, then you just put the boundary condition in it. Then you already have Low's equation. Then as long as you know the hypersine 0 equals to 0, the hypercosine 0 equals to 1, then therefore the C2 will equal to 0. And therefore the C1 equals to theta b. Hypercosine ml. Then just put it back into your equation, then you'll get the similar stuff we have. 这个就更简单了哦，不用从 exponential 那个地方慢慢推，但前提是我们前面已经知道你的 general solution 是什么东西了。这个方程式到下面这个被做一次导数应该可以哦。你的 hypercosine 就变成 hypersine， 然后你的常数拉出去，然后你的 hypersine 变成 hypercosine 一样，哦，你的常数拉出去，哦，这个要会，哦，不然这个也会通解，也会卡在这个地方。哦，对，我写相反，我先处理了下面的东西。下面那一行是西塔的一次导数，负 MC1 hypersine 0。哦，对对，我写错，不想写相反，我先写。应该是代表没错，我先写相反。Okay, so then if we want to know the rate of heat transfer, then if we want to find the Q, then we still start with the Fourier law. Let's do it like this, dx. Then we put the d theta or the d theta in, so it will be theta b. There is an equation, cosine, hypercosine, and that's this. Okay, then the theta b is a constant, then we just take it out. Then minus Ka theta b, and also we also can take it out the function without x, so the hypercosine ml out of the equation, then leave the theta b. Dx theta b cosine by hypercosine m. Okay, and that's quite obvious. Let's just do it again. Cosine. Then once you do the first order derivative, then just making sure you take it out the m correctly. Then the hypercosine will become sine again. Then this will equal to m k a theta b tangent hypertangent m l. Because this term它是 hypersine 跟 hypercosine 的合体，这就是 we spend quite a lot of time driving those equations. If you are interested in, but if you are not really interested in those mathematics, then you just memorize it. Okay, so that's the second case. So the tip is insulated. And the third case is the tip has a convection. Okay, so the first one is we didn't discuss about the convection. We just assume the tip temperature equals to environmental temperature. And the second case is the tip is insulated. And the third case is there's unknown is a known length, and then the tip has a convection， 就是顶部有明确对流，例如你的散热片上面加了风扇，或是明确的有风吹过去的那种 case。Okay, so let's take a look. Convection condition on the fin tip. So this will look like this. You have a fin, then there's a convection edge here. Okay. So from case 2, we already know never start with the very beginning. So we start with the general equation we have here. So let's start here. The general equation of the fin will be theta x equals to C1 hypercosine Okay, we'll start from the general equation. Then the boundary condition already listed on the slide. The first boundary condition, not to mention, when theta x equals to 0, then equals to the temperature on the base. So theta 0 equals to theta b. And the second boundary condition, since on the tip we already have the convection, so which means the conduction equals to convection. The Fourier's law equals to Newton Coulomb law. So as it shows here, so the boundary condition on the tip will look like this. So minus Ka and dx, dt dx at certain position, whatever, will equal to the edge times the area and times the temperature difference. So if there's a x equals at the tip, then this will be equal. Yeah, x equals to L. Okay, then the theta b will become now C1 hypercosine and L plus C2 hypersine ML minus K A, then put into become MC2 times 1 equal to HC2。好，我们的 L 就直接带进去了。哦 ，C1 C2。Then here we need to employ a trick. We are not directly finding out C1 equals to what or C2 equals to what, let's take a relationship of the proportion. So if we divide C2 with C1, then we know the relationship will be something with the convection, then the M and the K. Okay, so we took this from here. Then we need to create something, the relationship on the first one, to get rid of the unnecessary parameter. So the first one we divide C1, then zeta B C1 will equal to hypercosine plus C2 C1 sine. Then here equals to this. Okay? Now we have a relationship of the theta b, but still have a lot of unknown constant here. So we use the governing equation, also divide by C1. Then we have theta x minus C1 equals to this. Then we can combine these two terms together. 好，现在我们两个式子，那C1都有，我们就一起把它同除掉，这时候变成一个无因次的值，好，变成theta x theta b。好，我们前面很常在讲的这个东西，好，我直接给你答案，因为它就是直接两个相除去整理而已，我只是把课本的东西抄过一次。Okay, then we have a homework which you don't need to really submit on it. Try to find Q. What is the Q? 好，你有右边的这个值了，那我的 Q 应该要怎么算？好，试试看，从这个地方开始推导，好，用这个，看可不可以跟课本上面的数字是相同的。我们就不浪费时间。把课本的东西再写一次。好，这边的数学稍微有一点点多，但是就是耐着性子把它写完推导，应该是没什么问题啦。按没有兴致的同学也可以直接记结论。Okay, so this Friday we'll move to next chapter. It's called lump system. But before that, we're going to close the fin system by introducing how we evaluate the efficiency and effectiveness of the fin. Efficiency and effectiveness actually is two different terms. 一个东西叫做效率。一个东西叫做有效性，有没有效，多有效，然后跟它的效率有多好，这两个是不一样的事情。Okay, so we can move to the rest of part of this chapter. in your PDF might start with the efficiency, but let me start with the effectiveness. So the effectiveness means 有效性，它的中文就是到底有没有效。So the effectiveness epsilon is always larger than 1. Then become if you have a better effectiveness, then the epsilon will become higher and higher. 那它的定义是什么呢 ？So the definition of the epsilon actually is if you have a heated surface with fin or without fin, the ratio between with fin and without fin. 所以这个定义呢，其实是有装 fin 除上没装 fin 的值，可以吗 ？So if you have a heated area here, and this will be at the bottom part, and compare with the one with the fin. 好，它就是比值要有装 fin 再分子，没装 fin 再分母。Okay. So if you have fin, then you can directly employ the equation we have right now. Then if you have no fin, which means the heat going to propagate just via convection. 好，所以它的分母就是直接把 Newton cooling law 放进来，所以 H 乘上那个 area 发热的 area 乘上西塔，哦，温度差，这样可以吗？好。Okay. So if you have fin, the Q equals to the H times the total area you have and the temperature difference. And the ratio in between, there's something we call efficiency. 好，因为所有的热传一定不会是100%，所以它会有一个比值。那这个就是我们后面要讲的 efficiency。好，那如果我们现在不看这个 efficiency， 直接互相比的话，那它其实就是fin 的 area 除上你发热的那个表面的 area 的比值。好，如果我们不看这个效率的话，先不看的话，它其实就是面积的比值。Okay, so the effectiveness always larger than 1， 可以吗？你只要有装，你的有效性一定大于1。哦，因为你的面积比原本面积还要大。So always bigger than 1. Okay, so the last equation, the third equation here. This is an infinity long fin. 好，这个就是 infinity long fin。你把你的 Q， 我们算的 Q 直接带进来放在上面，得到的值。好，那如果今天你是 insulated 的 tip 呢，我把它写在这边。哦，课本可能没有写。如果你是 insulated 的，好，那这个也一样，我们就直接把它带进去。那后面有对流的也一样意思哈，就是你直接把它带进去就好了。我这边就不多写，我这边就先写了一个 insulated 的，好，你可以回去自己推看看。Okay, so how can we increase the fin effectiveness? So by looking at the equation, one thing you can directly do is we change the material of the fin, right? Then we make the K even higher. So we use the better conduction material. 用比较好的导热系数的金属，比如说铜，或是有钱人的话用钻石，最高的，然后或是比起用塑胶增加面积，我一定是用金属。So the thermal conductivity K should be higher. Okay, and the second, then we can try to make the pin as slim as possible. 好，我们可以让它的那个几何形状改变，所以 P 去除上 A 的时候，让它的值变高，然后它的表面积，它的周长对上它的面积的比值是高的。 And the last one is a little bit tricky. So the low convection transfer coefficient, if you put your fin in the low convection heat transfer coefficient, it will be better. Which means if you put your heated CPU with fin in a cooling water, the effectiveness isn't better than putting into the air. 可以吗？你要让你的 effectiveness 增加，你要让你的 fin 那一端放在有比较 low 的 H 值，那比起来的话，放在空气端会比放在水端还要好。
Which one is better, water or air?
Air.
But in real life, it's
Air, still in air, because now we are calculating the effectiveness. 这样讲啊，你有看过那个 immerse cooling 是装了散热片之后再放到水里面的吗？没有，因为不会比较好。所以如果你要装 fin 的话，请你把 fin 的尖端放在 low convection heat transfer coefficient 的环境当中。OK， 这有一点点违反直觉，所以特别把它拿出来讲一下。Okay, so now we finish the fin effectiveness. The second one we call fin efficiency. 这个就叫做效率。Then efficiency we call eta. Then the eta is always smaller than 1 because the efficiency is the relationship between the ideal case and the actual heat transfer rate of the fin. So ideal rate, ideal 的 case 是什么？就是我的热从最底部传到最外面，它就一直传，所以它的 conductivity 很好，所以整支的温度等于我 base 的温度。So the ideal case means the temperature of the fin doesn't matter which position, even to the tip, is same as the temperature of the base. In that case, it's ideal, which means the heat continues to propagate along the fin to the environment. But ideally, the temperature will decay, right? 我们都一直在讲这个 temperature 的 distribution， 它是一个 decay function， 所以它到 tip 的时候，它就会变成环境的温度，或是它变成比较低的温度，所以这个是 actual 的 situation. So the fin efficiency now is the ratio between the actual heat transfer from the fin versus the ideal heat transfer rate from the fin. 可以吗？这两个的比值。Okay. Then you can just quickly pop in everything. 好，直接把公式带进去，就没有什么太大的问题。So the first one will be the infinity long, and the second one is the insulate tip. 这个都是观念性的东西，那后面的作业可能会有一些题目是跟这个有关的，你就知道怎么去计算，那重点其实在于你会不会带这边的这个公式 ，OK。Then let's move to the total fin effectiveness. So if you have several fin, then we only talk about one fin of it, but usually in a fin system, it's not possible we have only one fin. It will be multiple fin and put it together. And how can you measure the overall fin effectiveness? That's the calculation you have here. 这就相对简单。你把 fin 的所有面积再加上没有装 fin 的里面的面积，去把它算起来的总热传算起来，那它就是你的 total fin effectiveness。那这个我们就不多讲了，这个还蛮直接的，这是纯粹的数学。Okay, then we probably need to move to the next chapter, but before that, there's a Junbier survey on the system. So please try to answer it before noon. Okay, that's the questions which allows me to shape the midterm 2. So there are several questions. Let me see. Like if it's too difficult for you for the first midterm or for the next year, heat transfer course, will you suggest the midterm 1 to be more difficult or slightly easier？ 跟你们无关，下一届应该要考比较简单，还考比较难。To be honest， 会不会大家要诚实？就是诚实说，对下一届的学弟妹来说，我应该考简单一点还是考难一点呢？我必须说，上一届对你们很好，所以我们这一届题目有比较简单一点。那我不知道你们希不希望把这个善意再继续 pass 下去，或者是你希望他们接受更进阶的挑战的话，那你就可以选1，这样好不好 ？OK。然后exercise in midterm 2, textbook exercise in midterm 2. So we plan to reduce the proportion of the text exercise in midterm 2. Do you think it will dramatically increase your study time? So 这就表示说，因为我们的那个作业没有很多，所以会那个就变成是我的考题。如果要从课本里面出的话，它就是有一些不会从你们的真正的assign给你们的作业当中出。那你觉得这个会非常影响你的那个研读这门课的时间吗？也是稍微了解一下你们的想法。OK， 然后那个最后一个是提醒大家，你的 progress on video homework， 已经学习中了，所以你应该 form a partner or start to find a paper and start to read it and then record a video or making the PowerPoint. Then 所以稍微 report 一下你现在做这个 video homework 的进度。好，那我们剩下2分钟，我们有一个那个 Kahoot 的 test， 邀请助教协助一下，来做一个第3章的 summary， 然后非常好连结进入到第4章。你要分享器，但是好像，好，我们把卡库处理完之后，大家再下课。需要 scan 吗 ？scan。 对，在第一次你可能知道有蛮多人。答案是 no。
Charger?
Next one. Now 4个问题。
有觉得
会记得吗？
I